Hi, I'm Sollutionel from FLYABILITY. We are here in a copper and zinc mine to create tutorial videos on how to do some inspection in mining. In this video, the purpose is going to be to show you which documentation you should fill up before an inspection, but also all the risk linked to the inspections. We will finish the video with checklists on what you should do on the ground before an inspection and underground on the drone before flights. The purpose of this video is to be able to cover some aspects that we won't cover in each asset-specific inspection. This way, we go straight to the point in the next videos.
Before any drone operation, you need to check and follow the country or region's regulations on drone operations. Not all countries have indoor drone regulations. However, it is good practice to check every 6 to 12 months for regulation changes. Then there will be some company regulations that must be followed for all drone flights. This will vary from company to company, but the most common documents which are needed for an indoor drone inspection are the UAV Emergency Response Plan. This plan is there to guide the pilot in command on the appropriate responses in case of an incident. The Underground UAV Standard Operating Procedure. This document is a general review of the steps required by the pilot in command and the crew at all stages of the flight operations underground. The risk assessment for an inspection. The objective will be to list the risk and the mitigation measures before deciding whether to do an inspection or not. The method statement is a document that describes the objective of the inspection, the criteria of success, and the output format of the inspection. The UAV pre-flight checklist is the checklist you should go through before flying the drone to make sure the UAV is in the best flying condition possible. Another important subject for underground drone operation is the management of the safety risk and their mitigations. Indeed, flying an ELIOS in a mine is not without risks. However, most risks can be mitigated or eliminated. This is a list of risks in mining and how to mitigate them. In each of the following videos, we will quickly cover the risk linked to the specific flight environment, but we won't cover them as we will do it here. Falling rocks. ELIOS 3 was made to increase the safety of all the workers of the mine. This is also true for the UAV team. The UAV team need to follow all the safety procedure to stay safe during drone operation. This means thinking about their safety first, not only during the flight, but also when preparing for the flight or while placing the range extender. When it comes to the risk of falling rocks on the drone, there are some mitigation plans depending on the environment, but the risk cannot be completely eliminated. This is why drones are sent and not humans. The UAV team must, however, evaluate the risk for the drone and find how to lower this risk when possible or accept it. Explosive gaze. ELIOS 3, like every drone on the market, is not ATEX. It is important to check for explosive gas before starting drone operations. Airflow. ELIOS can withstand up to 5 meters per second of wind in assist flight mode and 7 meters per second in ATI sport mode. It is, however, recommended to limit the airflow and ventilation during drone operation, as depending on the geometry of the underground tunnels, there will be some natural wind funnel with airflow much stronger than 5 meters per second. During the flight preparation, with the help of the blueprint, the pilot can most of the time foresee where there will be a risk of strong airflow. It is usually in narrow passages between different room volumes. Water. While ELIOS can withstand some light water projection, flying in heavy water is not advisable. After a flight with water projection, let the drone dry out for 1 or 2 days out of its box. Dust. Flying an ELIOS underground can generate a significant quantity of dust during takeoff and landing. The pilot must wear the appropriate safety goggles and respiratory protection according to the flight environment before starting the drone. A high concentration of dust in the air will also blind the drone camera and limit the visibility of the pilot. When possible, we recommend keeping some speed while flying in dusty areas to stay out of the dust cloud. Flying high instead of low to the floor will also help. When an area is saturated in dust, it is better to wait 10 minutes to let it settle. Your stability and visibility will be much better. High humidity. Quick temperature changes often result in fog on the lenses of the drone and affect the visibility and stability of the drone. To mitigate this, Allow the drone to acclimate for 5 to 10 minutes outside its box before the flight, and then clean the drone lens and LiDAR window before the flight. Loss of signal. ROC is considered a non-reflective environment when it concerns the radio signal. This means that after a 90-degree angle turn in the narrow tunnel, you might start to get signal degradation. It will not stop at once, but you will see the degradation on the top left of the cockpit screen, and you will get a weak signal warning. The use of the range extender is highly recommended as it can deport your antenna by 20 meters. This way, using a telescopic pole for example, you can place the antenna in an area inaccessible, like under or in an overpass or inside of a stope, to get a good signal while keeping the pilot in a safe position.